Well, hi, this is John Sarver. Welcome to the our GLREA Thursday evening Zoom sessions on clean energy. And first thing I'd like to do is to thank our two sponsors, EGLE, the State Department of Environment, Great Lakes and Energy, and also Harvest Energy Solutions is a sponsor for this month for our programs. And I'd like to encourage everybody to attend our 30th anniversary celebration, which is coming up this Saturday. It's going to be at 6 o'clock. It'll be a Zoom event. And you can register RSVP online at our webpage, glrea.org. And we have Doug Jester speaking. He's excellent in explaining fairly complex energy policy issues, and will kind of bring us up to date about the transition to, from fossil fuels to clean energy. And tonight, it's my pleasure to introduce Dwight Hawks, who's going to talk about energy efficiency opportunities in commercial buildings. You know, GLREA has always kind of emphasized energy efficiency first before you do solar. And so in keeping with that, we've had Dwight come tonight to give us some of his perspective. He's the president of Hawks and Associates, a certified energy engineer. He has extensive experience in energy management. He's been doing this, I think, as long as I've been involved with clean energy, which is a while. And like I said, he's going to be talking about energy efficiency and opportunities in commercial buildings with an emphasis on lighting. So with that, I'm going to turn it over to Dwight.
Okay, thank you, John. I appreciate the opportunity and the invite to be a part of this forum this evening. Thank GLREA as well as all the sponsors. So if I can figure out how to share this screen, I think we'll be in business here. So as John mentioned, we're going to talk this evening about some energy efficiency opportunities and facilities, primarily in the commercial area. But I'd just like to take a few minutes before I go into the presentation and just say that, as John mentioned, we try to encourage all of our clients, and you're going to see that this is focused on lighting, even though there are opportunities in HVAC as well. But try to encourage all of our clients to really focus on doing energy efficiency improvements, because you build a lot of waste into the system, the solar system, because if you really don't do the energy efficiency improvements beforehand, you may have a 0.5 megawatt of solar that you're using maybe for your commercial operation, but you really, to really run your operation from a facility standpoint, you really maybe only need 400 or 300 kW if you did some of these improvements. So I'm going to try to focus on a couple of examples, but I'm going to show you some of the things that we've been working on over the last few years. So hopefully this will work this time. If I page down, for some reason I tried this earlier and it worked. Okay, I'm going to just give a little bit of an overview about Hawks and Associates and what we do. Talk a little bit about the projects that we've done, and then I'm going to, because of time, I'm going to focus on specific LED lighting projects that we've worked on, Tabernacle Missionary Baptist Church, as well as Cristo Rey High School. And then we'll talk about some of the benefits, and then hopefully have time for some questions at the end. So we're basically a company that resides in the Redford Township area. We're an engineering group that identifies and implements cost-effective energy reduction opportunities for clients. We work in a couple different capacities. We work on the academic side with schools and universities. We do work in the commercial environment, places of worship, as well as, we do look at various manufacturing sites. And we've implemented some of these measures, as you'll see shortly, in some of these locations when I show you some of the clients we've done. We're able to not only work in the energy efficiency area, but we also work on the supply side with geothermal and solar. And then, as I mentioned, on the demand side, which would be where you use the energy within your facility, lighting, HVAC, water, as well as wastewater. So just to kind of talk briefly about some of the examples that I'm going to share with you is that in the lighting area, we've been able to see system efficiencies improvements anywhere from 65 to 85%. And that's primarily by converting from fluorescent lighting. In some cases, you have tube lighting, stab-in lighting to LEDs. So that's really what we've been focused on is the conversion of fluorescent and some incandescent to LEDs. To get to the 85 percentile, really you almost have to do some other things such as add controls. And I have one of the examples that we're going to talk about what we did and when we added those controls as far as in one of our clients' facilities. Also, and I know that because of time, I didn't want to really get into the heating, ventilation, air conditioning area, but we've done some things in the HVAC arena where we've improved system efficiency by 50 to 70%. So you may, not that we're changing anything as far as how the plant or the facility operates, but if you really look at a comparison of what you really need as far as energy in the facility, when it's in HVAC, you can do the same thing with 30% of the energy that basically you were using before. And then when you look at lighting, you're going to be using 85% to maybe a little bit more than that, 85 to, I said 85% efficiency improvement, but it would be 15 to 35% of the energy for lighting. So again, I wanted to stress the importance of doing these types of projects before you implement renewable energy projects so you don't build waste in the process. So just to kind of give you a list, and this is not totally comprehensive, but you can just see the diversity of the clients that we've been working with over the last several years, from, like I say, commercial clients like AT&T to, the bank industry, various, management companies, libraries, churches, schools, some small businesses, but that kind of gives you kind of a breakdown of the facilities that we've worked on, to larger facilities in the areas of Ford Motor Company, again, other churches, various property management companies, again, schools, teen centers, and even chip manufacturers, I should say, potato chip manufacturers. We've done work as far as in this arena as well. So that is just a kind of a list of some of the like I said, the diversity of sites and plants as well as facilities that we've done. So the first one I really want to talk about this evening and kind of focus on is this is a large Baptist church here in Detroit that we completed recently, and it's called Tabernacle Missionary Baptist. It's 2,500 seat sanctuary. You can see it's about 110, 110,000 square feet. I think that's actually on the next slide. 106,000 square feet. It has obviously church administration, community activities for the various area, the neighborhoods. Has 26 Christian education rooms, has 5 child development classrooms. They have a fellowship hall where they do a lot of work as far as for the community that holds 900 people. Has 2 commercial kitchens, media production room, as well as a very large parking lot. But as you can see, we did not only the inside, but we did actually the majority of the outside lighting. There's a couple areas that they did not do. This project that I'm going to share with you in a little bit more detail on the other slides, we actually were able to bring Michigan Saves financing as far as to the church and provide them with a low interest loan to do this energy efficiency improvement. As far as the scope, we were able to convert over 1,600 fixtures to LED. As you can see, the breakdown of 800 linear fixtures, several hundred in the biaxial and incandescent fixtures. They had 90 floodlights throughout this facility that we actually converted, as well as about 60 outdoor fixtures. In some cases, we had to work with different types of voltages because in some cases they had 120 volt, outdoor lighting was a 480 volt, and they even had some other voltages spread throughout the church. So what were some of the benefits associated with this project? We eliminated approximately $40,000 of electrical expense to the church annually. As far as when it comes to efficiency improvement, in this case, they are able to light that facility at 22% of what it cost them before we went in. So basically, we took 78% of the energy required out of that facility. We also eliminated about $9,000 worth of lighting maintenance. And this particular facility, we just recently got a letter from the pastor there, and they're just thrilled. And I was going to share that, but it's kind of hard to read because of just the small font. But we'll probably be putting it out on our website here shortly. But their utility bills were approaching $120,000 to $125,000 a year, and basically we took a third of their energy out due to this project. They, in addition, received about a $9,000 rebate. They would have had a little bit higher rebate, but the rebate program changed. Originally, they were closer to $13,000 when we actually implemented this at the beginning. But still, we got $9,000 worth of utility rate rebate from DTE Energy. Then, as I mentioned, this project was financed through the Michigan Saves program. The next project that I'd like to talk about is the Crystal Ray High School that we did recently. Actually, it's just finished up late last year. It was actually done during COVID in the city of Detroit. And this particular project, we converted about 500 fixtures. It's a smaller school, but it's still a good sized school. 380 linear fluorescent fixtures. There was just under 100 incandescent fixtures and about 25 biaxial fixtures. Then we did a number of outdoor wall pack and canopy fixtures around the school. One of the things that we didn't do at Tabernacle that could have been beneficial, but they didn't offer some of the incentives that they offered on this particular project. But we added controls to this particular project to do motion sensing and a touchless. In other words, no one ever has to touch a single switch in this entire facility, because we are using motion sensing to turn the lights on as they walk into a classroom or a conference room, and then even a hallway. And then we're also doing daylight harvesting throughout that facility, because they have a number of windows in all the classrooms, and that was a big benefit. We eliminated about $25,000 of their electrical expense. We were able to, we're about 85% more efficient. So again, we've, taken it up another 7-8% as far as reduction of lighting costs because of the fact of using controls. Eliminated their maintenance by about $3,000 to $4,000, and this was quite significant. They also received just about a $20,000 utility rebate. So in this particular project, again, we were able to finance the project for them through the Michigan Saves program. we do quite a bit of work with Michigan Saves and the Ascentium Capital folks on a number of the projects that I showed early on in the presentation. So just, I didn't know what the audience was going to be like as far as on the call or the Zoom call this evening, but we really look at what the availability and what kind of cost savings our customers are looking for, what kind of efficiencies they would like to, whether it's looking at lighting, HVAC, maybe there's things we can do for them in power quality when it comes to improving their power quality, as well as looking at other aspects of electricity and reduce their consumption. We really try to source various products for the client. We aren't tied to any particular product, but we try to find the best solution for our customers to achieve their energy objectives. So after we do an audit, this is kind of the process we go through. We put together a report, and that report basically sets up the process as far as what we would put into the facility, and basically start looking at what is the decision process that we're going to go through to determine which lighting goes into which areas. We do the design. As I said, we are able to design, order, and install. So we not only just do the upfront assessment. I do have a crew of electricians, as well as you don't really have to have an electrician to retrofit lights, but we do a lot of other electrical work. So we typically use more so apprentices to do this kind of work with someone that has a strong electrician background. So we hope that the state-of-the-art technology that we implement obviously provide the benefits, and we do try to circle back with our clients to make sure that they're achieving the results that we identified in our initial audit or assessment. So that really concludes, my presentation for this evening. I wanted to make sure there was enough time for questions. So I want to thank everyone for their attentiveness. Thank you. Oh, I do have one other slide. I guess I'll share real quick before we get into the question and answer. Probably should have been done differently. But if this is our contact information, as far as phone number and email, if you care to reach out to us. So again, thank you for allowing us to make this presentation this evening.
Hey, thank you, Dwight. That was a great overview of some of your projects and how you approach energy efficiency in commercial buildings. And like you mentioned, you were emphasizing lighting, but obviously there's some HVAC opportunities that can be significant, which we can maybe get into in another session. But
I'd love to do that.
Yeah, for folks, probably everybody on this knows this, but if you have a question, why don't you raise your hand? Because you can go down to the reactions button at the bottom there, and there's a way to raise your hand. That just makes it a little easier for me to kind of see what's going on. Charles, you have the first question.
Yeah. First of all, I want to give a big amen to what saying. I think this is that do the envelope first, and then build it up, and then every dollar saved is a dollar can put in. In fact, when I did this way back approach with an audit in 1997, way back in the day at St. Elizabeth, we reduced peak energy demand 60% in 5 years just by energy efficiency.
Yeah.
Lighting and windows and some insulation, and as a result, demand charge by the city was reduced to another $300 a month. So there was the compounded interest for the better. And then that became, because in those days we didn't have Michigan Saves anything. Those energy efficiency savings then became a financing mechanism for the on-site renewables, which then it was all said and done, we had over 70% reduction in our total energy cost, from where we began the journey where we ended up. But my question is about things like daylighting. You mentioned harvesting daylight, but have you used like, because maybe work with architects, but skylights or solar tubes, is that part of it? Because it's, it saves lighting that way. Plus it's, psychologically it's healthier if there's more, kind of a
Right.
daylight, especially solar tubes. You don't have to, at least some of that twilight time.
Yeah.
You can.
Yeah, in this particular, neither of these projects, we didn't use those technologies. The daylight harvesting that we did is basically put a dimming ballast with a dimming LED lamp. We found that we can actually dim most of the lights in the classroom substantially. And in fact, they have gotten so used to the dimming in the classrooms and the hallways, we're running everything at about 55% of load, design load. So if you're using, in most cases, we used a 13-watt GE lamp in each of the fixtures, and there's 4 lamps in each of those fixtures. So instead of pulling 52 watts for the 4 lamps in each of the fixtures, we're at 55% of that. That's how beneficial the dimming has been. But then obviously, in addition to that, when there's daylight, they dim even further from that baseline. So they never go over 55% right now. We designed it actually a little bit higher than that, but that was really as a safety factor on our end. But the point is that the daylight harvesting lowers that. We're probably somewhere in the neighborhood, and I'm trying to remember the numbers that we turned into DTE, but for the daylight harvesting, I would say we're probably closer to 40 watts a fixture. It's almost to the point where maybe we didn't even need one of the lamps because we're, 3 13-watt lamps would be 39 watts, but we're right around 40 watts, if I remember correctly, with daylight harvesting, but that varies depending on the amount of daylight you get.
Go ahead, Janice. I see you got your hand up.
Thank you. I can't see the controls below, so I wasn't sure how to do it.
That's fine.
Thank you for your presentation. I know that a great deal of heat is saved from going into the space when you change over to LEDs, and that affects the HVAC. Did you do any calculations to see how much air conditioning cost you abated by switching these to LEDs?
We did not. We did not. We know that there's obviously, as you indicated, thank you for your question, the fact that the LEDs don't really produce any heat to speak of compared to a fluorescent lamp. But we know that the cooling load has dropped substantially, but no, we have not done that analysis. We are looking to work with the school a little bit more recently as far as on that. The church probably has even a better chance of, because they air condition the entire church, where the school, they only air condition the classrooms. They don't, well, I shouldn't say that. They have window air conditioners as far as in all the classrooms and office. They just don't have air conditioning in the hallways. So, but no, we did not do that. Short answer is no, we did not, unfortunately.
Okay, thank you.
Hey, Dwight, we've been reading, or I've been reading about, supply shortages. People have a hard time getting home projects done and construction, and 2x4s cost a fortune now. I was wondering, in the types of projects you do, are there any supply issues, or is that not a big deal?
There are. Very good question. We had a lot of challenges during COVID being able to complete this project. We started out on basically a 6-week schedule, which turned into about a 20-week schedule because of delivery delays. We couldn't get material. It was primarily due to just being in the midst of COVID last year. I don't know if it was so much the manufacturers were having problems. I don't think that's, at least the feedback. I did not get that. It was more of just delivery of material. There were just all kinds of delays as far as, trucks not delivering material on time. And so it created kind of a backup in our, delivery of the completed project by the end of summer. We were still working on it, I would say late September. So, where we had planned to finish it in early August. So,
I'm going to switch tracks a little and ask about geothermal and heat pumps, because we've had a number of presentations on those technologies. And I'm just curious, are you running into good applications for geothermal? And also, apparently air source heat pumps now have become more effective for cold climates. And I wonder if those have become kind of an option that are considered in the sort of folks that you work with.
Well, we're starting to, we just brought on another mechanical engineer to work in that arena, because there has been an increased interest as far as in both of those areas, not only the geothermal, but also in the heat pumps. And I see a great opportunity as far as for us to do, probably even, I don't want to say it's going to be as attractive when it comes to incentives from DTE and consumers, but I would say that I think there's still some very significant energy efficiency opportunities there, and we can share more of that. We've done we've been working with EGLE now for about 7 months, maybe 8 months, on the HVAC program that they've implemented for a lot of the schools. So we've done about 25 or 30 schools here as part of an assessment, and that has come up as far as a couple times in some of those assessments, opportunities to do things with heat pumps, but not so much geothermal with those. But in our analysis and the report out that we have to give to EGLE, there's a lot of opportunity there for the heat pumps.
Okay, that kind of confirms what we've been hearing from some other folks, that there are some good opportunities now. Isn't it amazing how lighting has been a good opportunity for, I think, the last 40 years? But the technology keeps changing, and so then there's a lot of different things, right, you can do with lighting. So it's amazing how we've had good paybacks for lighting for, like I said, 40 or more years. But do other people have questions?
Right.
Any Janice, you're on, okay.
I was thinking of one. I was thinking how to phrase it. I know that switching to LEDs makes a significant difference, but also the application of controls make a big difference too. Could you elaborate on your daylight harvesting methods that you're using and how effective you think they've been?
Well, I mean, okay, another excellent question. I think that right now, the daylight harvesting that we found, even though we have a dimming lamp and a dimming ballast as far as in these fixtures, even though there's plenty of daylight, they may be at 10% power consumption, but it's not like you're sitting in the classroom and all of a sudden, or in an office, and all of a sudden, oh wow, the lights went out. Well, because they never go out. I mean, you don't even realize that they're dimming. So I think the part that's really been nice about this particular application of using this type of technology is that you really are saving additional energy, because of the fact that you don't have to turn a switch off when you leave the room. They go off. They actually have them on a 15-minute, which I think is a little lengthy, but they have them on a 15-minute delay for the motion sensing. I think they can tweak that down to a shorter time. But more importantly, on the daylight harvesting question that you asked, I think that they've been very pleased with the fact that the students have better learning, because they don't have the buzzing from the ballast. They don't have too much light. We've maintained a certain level of light. There's so many foot candles in every room. And they're very, very pleased that some of the rooms aren't overlit and underlit. So I think that the daylight harvesting has been a big benefit. Did I answer your question? I don't know if, did I fully answer your question?
If you could comment on what part of the savings you think was contributed due to the controls, as opposed to just changing out the lights.
I see. Okay, I'm sorry, I misunderstood your question.
Oh, that's okay.
Typically, it's very hard to calculate daylight harvesting. Obviously, you can't. It's not something, because this is the savings figures that I prepared for this presentation are all calculated based on input from a client. Hours of use, their bill, breaking down the bill as far as usage and demand, how is how we come up with that. But when it comes to the daylight harvesting, we just kind of use a 10% is really what we use for daylight harvesting. Controls, we're probably closer overall about 28 to 30% on top of what you would save just with
Okay.
the normal, switching over to LED. So I think the short answer is 30%.
Okay, thank you.
That's a good estimate.
This is John Freeman. I'm just curious if there are further, John Sarver made a reference that there's always research going on to improve lighting. Do you see something over the horizon that will be even more efficient than LEDs? LEDs seem to be, frankly, revolutionary. And I'm just wondering if you see developments that will continue to reduce the amount of energy, but still produce the requisite amount of light that we need.
Well, that's a good question. I think, and this is what I've seen being in the industry and primarily in the lighting piece for the last, 5-6 years, there's been a substantial improvement in the efficacy of lighting. You may recall that fluorescent lighting, which obviously a lot of that goes into heat, but your fluorescent lamp is typically 28 to 32 watts. If you've got a higher efficient lamp that's going to produce similar amounts of lumens, you're going to be at 28 at a very, very least in a 4-foot fixture. But typically, most people don't want to pay the extra cost for the 28-watt fluorescent lamp. So most lamps are at 32. When it comes to LED, used to you would go with a 18-watt LED. You can get the same amount of light out of a 10-watt fixture as you can out of a 10-watt lamp as you can out of an 18-watt, and in some cases even more. So your efficacy, the power consumption per lumen is continuing to drop. So the efficiencies of the LEDs themselves are becoming more and more efficient. You never think about the fact that you can buy a 10-watt lamp, and probably 7 years ago that same lamp was 18 watts. So you're almost 50%. So that's where I see the industry is that they're going to continue to be more efficient at producing the light out of the light emitting diode. Does that answer your question?
Yeah, there was a question in the chat about mini splits. Could you talk about mini splits as it relates to air source heat pumps, and what's the difference, if any?
Oh, that's a technology that I'm going to have to defer to my mechanical person. So I can't, if I was to answer that, I can't right now. But I'll be willing to address that in a future session.
Okay, and there was a question I think was answered, but could you give us a brief description of what a foot candle is?
A brief description of what a foot candle is. It's a measure. It's a measure of the amount of light. That's not the so-called, I'll say, Webster version of it, but it's actually a way to measure the amount of light emitted at a certain level in a space. So when you go back, and we do this to protect ourselves, but if they've got 30-foot candles on a work surface, we want to make sure that they still have 30-foot candles of light on that work surface.
Why don't you make a distinction between lumens then too, because we can, we buy a light bulb in the store, we can see how many lumens come out of a light bulb. And
right.
What's the difference between lumens and foot candles?
Foot candles you measure. Lumens is tracked as far as from your illumination chart, because that comes off your photometrics, because how the photometrics are determined when you put let's say you've got a high bay area and you're doing photometrics to make sure that you've got equal amount of light throughout the space, that your fixtures are 25 feet in the air, you're measuring the lumens off of those diodes to get the foot candle, desired illumination standard foot candles that you have to have on your work surface. So you're
Oh,
not
yeah.
measuring lumens typically on that work surface. You can, but that's not typically how it's done.
Yeah. So foot candles is really kind of a measure of what you need to do the work.
Well, it's
The
a
lighting-
standard.
Yeah,
It's a standard.
yeah,
It's a standard that you're trying to achieve, because like in a mall, you may have a desire to have 40-foot candles, where on a work surface in an office, you may only need to have 30 to 35-foot candles. Or in a parking lot, you may only, it's a standard of maintaining an average of, 1.5 or 2-foot candles, depending on, it varies from area to area. But you can measure typically foot candles off of, a meter.
Mhm.
Or lux. You can measure lux too.
Janice, did you go ahead? Janice.
Yeah, a foot candle, and I'm going to read it, is a unit of illuminance on a surface that everywhere 1 foot from a uniform point source of light of 1 candle and equal to 1 lumen per square foot. And if you're to convert between them, I believe it's 10.76 lumens is equivalent to 1 foot candle. But all of the standards for illumination for a surface are based on the type of works being done, the
Right.
detail of the work, all of that. And it says at the surface is what they're looking at, how many foot candles you want measurements of. So I hope that clarifies it.
Oh yeah, that's very accurate. I just didn't have it off the tip of my tongue, but yes.
It's okay.
Thank you. Thank
You're
you for
welcome. I
sharing
used
that.
to teach it, so I hope I know a little bit about it anyway.
Okay. Well, that was very good. Well, I want to ask the question. I was gonna say, what did you teach? So,
I taught in the College of Architecture and Design at Lawrence Tech, and also the architectural engineers. And I did teach
Okay.
some lighting, in that, as well as HVAC, high performance buildings, and solar energy design.
Okay. Lawrence Tech's a great school.
Hey,
I'm
Dwight,
Professor Emerita now.
Oh, okay.
I've retired. I'm
Oh.
older than I look.
Okay. You don't look old enough to be retired.
I like to hear that, but I am.
Hey, Catherine, did you have a question?
Thank you.
You got on mute.
No, I was clapping my hands at her.
Oh, okay. You're clapping. Okay.
Yes.
Well,
Kudos.
I got a question for you, Dwight, because I found it very interesting the school where the basically no switches anymore, and it's all being controlled. And I found it interesting because I remember it was a little while back. They used to do that in science fiction movies for what's going to be in the future. Like lights would come on and off, and now it apparently is becoming at least. I guess my question is this kind of becoming kind of standard kind of procedure with controlling all the lighting, or was that unusual?
Well, I think it's kind of interesting. I'm glad you asked that question, because it's kind of interesting how this evolved. Because of the fact that at this point in time, when the school was looking at doing this project, they had received I'll call it a bonus, to implement a control system at their location if it related to energy management. DTE was offering a 30% bonus to certain, I don't want to say commercial, may have been just academia, but the bottom line is that was what really made it attractive for the customer. First of all, they said, well, how much is the control system going to cost us, and how much more will it save us? So then we had to do that analysis. So basically, when it comes right down to the end of it, they got a control system for free, for all intents and
Wow.
purposes. And initially, they weren't looking at doing all the touchless all the motion sensors in the classrooms. And so right now, there's a way to override, obviously, the controls, because each teacher has what we call a remote switch, but only the teacher has it in her desk. Now that's obviously, so they can really turn the lights off if they don't, need them on because they want to show a presentation. But what they really liked about it, because we were in the midst of COVID, they said, this is perfect because now no one has to touch those light switches on the, wall in each of those classrooms. No one has to touch anything in the hallways, in the office. So it was really kind of a real big deal because we were in the midst of the pandemic. So it started out, like I said, because of the additional incentive from DTE that they received if they implemented these controls. And then when they found out they could implement the controls for basically what the additional incentive was going to provide, there was all these other benefits, tangible benefits that grew out of it.
John, Abraham has a question.
Go ahead.
What do you use control systems like the types Radio Ra from Lutron, for example? Are you familiar with?
What type of control system?
So lighting control systems from Lutron, Radio Ra and Radio Ra Select and Whole Home and all of that sort of stuff.
Yes, we have, in these two examples that we do have some of their technology in both of these buildings. I mean, obviously the church was not to the magnitude of being touchless or anything like that, but we have some motion sensors that are Lutron, but the system, the control system, they're not standalone controls like they are at the church, but the control system is actually made by Mattis Controls, which is out of Colorado. But they were one of our partners, and we partnered with them because of their functionality, the reliability, and then they could meet all the incentive requirements to get the additional incentive from DTE. Like I said, they got, I think it was roughly another $6,000. I think, if I'm not mistaken, $6,500 that they received because of the control system for the lighting.
So do you also do control design with specifically Lutron? I happen to have an interest in. You do, okay.
Mm-hmm.
Do you also work with shading systems?
We don't do, we haven't, I'll put it this way, we have not done really any with shading. Well, let me make sure I understand what you mean by shading. You're talking about as far as in the sense of pulling down a blind?
In both temperature control as well as lighting opportunities?
Yes. Yes, I think if I'm answering your question, you're saying, or repeat the question to make sure I'm answering it. Do we?
So in order to reach the energy efficiencies, I think the most efficient ones, especially in rather diverse population in your buildings, automation and control can be a key factor in reducing your energy requirements. And I just wondered whether you look at that whole package and whether you actually do that in a design, or whether your firm approaches it from that perspective.
If I may, I think, are you asking if perhaps you had specified using light shelves to bounce the light up, so it's not coming in as a glare, for example, that sort of thing,
Right.
and also shading light from coming in to keep it from overheating.
Yes.
Yeah, we didn't look at those particular classrooms or areas in any of the examples I gave and looked at these as solutions. And primarily because of the cost, we were given, we try to work within this 2 to 3 year payback, as far as on these, projects. If we can get a project in that realm of 2 to 3 years, it's almost a no-brainer, especially if we can provide the
Right.
financing and the low interest loan. I think some of the things that you just mentioned may have provided some benefit to those owners of those buildings, or the occupants of those buildings, but I think it would have lengthened the payback. So we don't look at all solutions. We look at some of the high payback solutions for these occupants of these buildings.
John Marino had a question as well. I don't know if her question was answered or not. Do you see, can anyone give a rough idea how much energy is saved by using daylight harvesting and occupancy sensors?
It's in that 25 to 30, 28 to 30%. I mean, for daylight harvesting, we kind of say it's a 10% improvement, but it just depends on, I think, conservative. I think that if you've got a building that has mostly windows, there's a good chance that you can get probably more than the 10% additional savings just for daylight harvesting.
Hey, thank you. And Charles, do you have a question?
Oh, I was just going to
Yeah.
say that you said you called on me, right? I'm sorry.
Actually calling on Charles, but you'll be next. Charles, go ahead.
Sorry.
I just, my question had to, if you did energy, you know, like you're doing this, an energy audit, then you did things like blower door testing, you did things like building envelope in terms of heat loss as well. Is there anything there in terms of what you did to tighten up the envelope? And some of that can be very simple things, from door stops to caulking to just, did that factor any and the improvements you did to, you know, reduce load?
This was a lighting audit only.
Oh, okay.
Yeah, we did not do any. Well, at this point in time, we've had some discussion now that they've seen the results these last few months of comparing year over year their cost for electricity. Obviously, there's some anomaly there because, you know, they've got some of the students back in the building, but still they feel that they've made some big inroads into cost savings. So now we're talking about the HVAC side.
Okay, go ahead,
Building
Jane.
envelope.
I'm not
Okay.
talking about did that just fall, not just HVAC, I'm talking about the actual building envelope itself, windows, doors, that kind of thing, tightening it up so that you can reduce the demand for HVAC.
Right. And that's part of the scope that we've been talking to them about. Yes. Yeah. Thank you.
Go ahead,
Thank
Janet.
you for your question.
Thank you. Sorry, Father. Lighting is probably has the biggest impact at first. And so that's a great way to start. But as Father Charles had mentioned, it's very important to take care of your infiltration for the building, as well as looking at the HVAC. But I had also another comment I wanted to make. I'm personally very much upset when I go in and I have a motion sensor. I used to have one in my office, and if I was too still for too long, the lights would go out and I'd have to wave and do all this. So I was wondering, have the people that you've done this for been upset by anything, or do you also do heat sensors so that you don't run into the problems with lights going off if a person or people in the room are too still?
Very good question. I think if you go with just the basic motion sensing, like the wall sensor, it's indicative that you're going to have that issue. As we take the step, and if a client is willing to invest the additional monies to do, you know, ceiling sensors, and we can mount those as far as off of the fixture or in a drop ceiling, whatever it might be available to us. That is not indicative where the lights go off because, you know, so we've been more successful, but obviously if you're not moving, that's a problem. But if you go with the infrared where you're sensing heat, you know, you could not move at all as long as it can sense your body temperature, you're in better shape. So I would say that We haven't had that complaint as much on this last major project where we did the controls using, infrared motion sensors. So in fact, we haven't had any complaint, which is kind of surprising. So I hate to say this, but it's almost like we placed them perfectly because it hasn't been a complaint. So kudos to the team for doing that. So
Maybe students move around a lot too.
that could
That's
be.
true.
That could be. I'm sure that's the case. So,
Hey, Dwight, can you give us a definition of an air source heat pump?
told you I'm gonna have to defer those questions to my mechanical person.
Okay.
I'm the lighting person. So,
Okay.
and that's why I said I would really love to do this again. And there's some tremendous opportunities of what we've been able to do in the HVAC industry. HVAC sector. So, but no, I cannot. Short answer is no.
Maybe Janice wants to answer that.
Yeah, maybe she wants to address that.
An air source heat pump uses air rather than water to make the heat exchange. And until very recently, for our environment, if you were using an air-to-air source heat pump, its coefficient of performance, which defines its efficiency, would start dropping, at about 40 degrees until it stopped operating close to freezing. But newer air source heat pumps are coming out right now. And I saw that in the chat that someone had asked if they were being used with mini splits. And I think that's where they're primarily being used right now. I don't know that much about air source heat pumps that are being developed. I just know that they're better now than they used to be.
Thank you.
We're gonna bring you onto the team, Janice. You're gonna have to come out of retirement.
Now
I
that you're
am
emeritus,
consulting a bit.
Yeah, we got to bring you out of retirement. You sound very knowledgeable in this. Thank you for that answer.
Thank you.
and, we probably have time for one more question. Any further questions? Let's see, John, do you have any kind of closing remarks you'd like to make?
Well, I just want to thank Dwight for joining us this evening and thank all the GLREA members and everybody who joined us. I thought it was a very interesting session. This is probably the first energy efficiency solar story we've done, and I'm really glad we did it. And we will certainly have Dwight come back to talk more. And I just want to remind all the everybody about our mid-year strategy event. It starts Saturday at 6 o'clock. I'll be sending out the Zoom link tomorrow. And so please join us Saturday at 6 p.m.
Okay, super. Hey, thanks everybody for coming and hope to see you next Thursday and I hope to see you Saturday. Take care.
Yeah, thank you. Thank you for having me.
Hey, thanks, Dwight.
Thank you, everyone.